Okay, now we're going to look at one less example here, probability and coincidence. So the word coincidence, it literally refers to one or more incidents happening together, such as, spell check there, two events happening in the same place or at the same time. However, in everyday language, we usually call something a coincidence only when it seems surprising in some way. And these things come in many different forms. And one we're going to look at is birthdays here. You may be surprised to find that two people at your dinner party have the same birthday, or that a friend's mother met your mother on a trip to China. You might flip a coin and get ahead 10 times in a row, or have a dream that seems to predict an event that later occurs. It's tempting to chalk these up to something more mysterious than mere coincidence, but the laws of probability dictate that many coincidences are bound to happen at some point, even though the particular form of coincidence seems to be unpredictable. So we're going to look at birthdays and the coincidence of birthdays. So suppose you are part of a group of people at a dinner party, and for this situation we're going to find the probability that at least one of the guests has your birthday, and then the probability that some pair of guests share the same birthday. So the first part is you're a group with a party of 20 people. What's the probability that that someone shares the same birthday as you? So we were looking at the probability that at least one person, so at least one shares birthday with you. Okay, when you see that at least one, hopefully you think 1 minus the probability that none share with you. And so we're going to be 1 minus, now the probability that no one shares with you. So, if we look at one person, if you pick your particular birthday, then there's a 364 out of 365 chance that that person does not share the same birthday. They're one of the other 364 days in the year. So that's one. And then, for each possible individual, there are 19 other individuals besides you at the party. So the probability that no one shares your same birthday would be 1 minus 364 out of 365 to the 19th power. That means that all of them do not share the same birthday as you. And this is going to be, let's see here, 0.0508 on your probability scale. So a pretty low chance there that someone's going to share the same birthday as you out of the other 20 individuals or 19 individuals, because you are the 20th member of the party. Okay, and that's just looking specifically at you. But now we want to look at all of the members. So what's the probability that at least one pair share a birthday? Oops, birthday. So again, this is going to be probability would be 1 minus the probability that none share a birthday. And again, now we're looking at all of the different possibilities. And so here's where we kind of have to think about how we would look up and set up this scenario. So if no one shares the same birthday, then that means that if we look at you, so again, we take 1 minus the probability that the first, or that no one shares a birthday is, when we look kind of at the first group of people here, 364 out of 365. So that's, the first person's birthday is 364 out of 365. Then that day is taken, so we have to bump it down to 363 out of 365. And then that takes another day. So say this takes January 1st and January 2nd if two people have those birthdays. So no one can have those birthdays. And then we're down to 362 out of 365 for the third person. The fourth person's birthday, 361 out of 365. And then the fifth, 360 out of 365. And so on. And so then we go through here and we keep multiplying these down until we get to, the last people, and, we would have 346 out of 365. And, that's going all the way down through, and we have 19 different possible, when we pair the people together, we're going to have 19 different possibilities there. So we're going to go all the way down to 346. And the way you can just double check for 346 is take 365 minus 19, and that's 346. So all of this equals, notice that all the denominators have 365 because there's 365 days in a year. These are all decreasing by 1 because each time we're multiplying these probabilities together, we're taking up a day, and so it reduces the number of days we have to select from. And so then you get 1 minus 364 times 363 times 362 times 360, and times all the way down, times 347 times 346. All of this would be divided by 365, and it's going to be raised to the 19th power. And that's going to be the probability that at least one pair in the group share a birthday. And I've got to run this through my calculator real fast because it's giving me an overload here, so I got to find a different calculator that can do it. But give me 1 second, and I'll be right back. Okay, so I found a calculator that can crank this out. And when I do 1 minus 364 times 363 all the way down to times 346, then I divide it by 365 to the 19th power, I get 0.411. And so that tells us that there's a 0.411 probability that at least a pair of guests share the same birthday, or a 41.1% chance. And to a lot of people, that's surprising, that the probability is so high amongst a small number of group of 20 people. But again, it's not just a coincidence, but from a probability standpoint, the likelihood of it happening is relatively likely or significant. So that's a look at how you would look at the birthday coincidence problem. It's one that a lot of people look at and find quite interesting. But if you have any questions, please don't hesitate to let me know. And that wraps up Unit 7E for us.